Let's start. Here's where it gets really good as far as I'm concerned. This is the alphabet of the periodic table of the element of the universe. The periodic table is how the universe spells. I wrote this down. It's not in your notes. This is from Richard Feynman, who won a Nobel Prize in physics. Someday I'll go on a Feynman rant because he's one of my favorite scientists of the last century. But here's what he said. If, in some cataclysm like a zombie war, all scientific knowledge were destroyed and you could only pass one sentence on to the next generation of creatures, what sentence would contain the most information in the fewest words? I believe it is the atomic hypothesis, or atomic fact, or whatever you want to call it, that all things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are being a little squeezed, a distance apart, but repelling upon being squeezed into one another. In that one sentence, you will see there is an enormous amount of information about the world if just a little imagination and thinking are applied. Say what? I have a worksheet. We're going to be working on the worksheet later. It says familiarize yourself with the names of the elements on the periodic table and why and where they are. And I already played for you the video, the periodic table of the elements song. So let's get to the notes. Let's meet the elements. I think this is what it says, right? Yeah, let's meet the elements. So now you're with your notes, filling in the blanks. There are, it turns out, 92 elements that occur naturally in the universe. How high does, sorry?
The first, chapter 2, blank, and
periodic table.
Elements in the periodic table, I think was what it was. Let's go check. Yeah, there you go, chapter 2, elements in the periodic table. Here, I'll get a copy so I can kind of follow along. And then, let's meet the elements. So there are 92 that exist in the universe naturally, but look at your pink periodic table. How high does it go up to? 100 and what? Oh, no, it goes further than that. Look close. You gotta go hunting a little bit. So it's not the very, very bottom row. It's the bottom row of the actual table. But by the way, the reason is those bottom two rows should fit in the middle. There's a little arrow showing where they should fit. But if we stuck them there, those middle rows would be too wide to fit on the piece of paper. So one of the things we do with the periodic table is we cut out a middle chunk and just move it at the bottom. We're not going to be dealing with those all that much anyways. They're some of the weirder elements. Sorry, how many have we right now? We're able to create those remaining ones past element 92. We create those in labs. Particle accelerators. That's what they're doing at the Large Hadron Collider, the LHC, that you may have heard about in Europe. They're literally speeding up elements almost to the speed of light, smashing them together, and they're hoping that their nucleuses stick together. And if they do, maybe you've just formed a new element. However, Kiana, almost all these elements past element number 92 don't exist in nature for very long. In fact, some of them only exist for quadrillionths of a second. Some exist for a few seconds. Most of them are radioactive and they decay. Everything else in the universe is made up of combinations of these elements. All elements are represented by a 1 or 2 letter symbol. Write that down. And then when you combine elements, we call them compounds. We'll learn how to represent compounds next unit. Some of these make sense. Okay. Carbon is C. By the way, if you miss a blank, instead of asking your neighbor, leave it for now, and then you can get it later, because otherwise you're missing out what we're currently doing. That's my suggestion. I'll bring it back later if you need to. Okay? So some of these make sense. Carbon is C, some of these don't. Gold is AU. Why? Because not all science was done by people who speak English. Sorry. A lot of the chemical names come from Old Latin or Old Greek because some of the older elements that were found a long time ago, that was the trend. You did all your science, you wrote all your science in Latin or in Greek. A lot of the elements were discovered in a small town in Sweden. Almost any element that begins with a Y or a YT was found in the town of Yttrium. There's a mine there that some of the elements from the middle of the earth just bubbled up in that one mine, in that one location on our planet. And so 200 years ago, as they were mining, they kept finding these new elements. And so you'll see there's ytterbium, yttrium. There's a few that begins with a Y on your periodic table. Headphones. This is not in your notes. What are they made of? So just to let you know how some of these impact you, a standard set of headphones has copper, which is an element that carries the signal from the music player to the headphones. Copper is a good conductor. We'll learn about that later too. There's gold in your headphones. It helps transmit the signal. Gold is also a good conductor. There are magnets which convert the signal to sound, and those are made of iron, boron, and neodymium. Neodymium is often called rare earth magnets.
There's gold.
Yep.
So you can just take the gold out and sell it?
Except it's a very, very, very small amount of gold. Gold, in all honesty, Matteo, is not that valuable a metal when you compare it to some of the rarer elements. It's valuable in that it was easy to find and it's pretty, and that's why it dominates our currency. But there are other elements that wars have been fought over because they're much, much rarer. There are three main groups, back to our notes. Metals, nonmetals, and then there's the third group that we're going to talk about a bit, Lena, but not do a big song and dance. They're called metalloids. Metalloids sort of sometimes behave like metals, and they sort of sometimes behave like nonmetals. They don't quite fit, much like teenagers. Sometimes act like adults, sometimes act like kids. I think of you guys as sort of metalloids. Metals, which are most elements. They are usually hard at room temperature, except mercury. Mercury is the only metal that's liquid at room temperature. They are usually shiny, and this makes sense. When you think of the word metal, hopefully you think of something that's shiny, Candace. They conduct electricity. They're malleable. What that means is you can beat them into sheets, you can mold them, you can melt them. They're ductile. That means that you can form them into wires. Yeah, I'll pause. So with the one exception of mercury, I'll say to you, metals are solid at room temperature. And the fact that mercury isn't actually turns out to be really, really handy, but also mercury is very, 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 very toxic. So we use it in industry, but we have to use it very, very carefully. And I'll show you why that whole liquid part of mercury is handy. So some examples. Oh, sorry. Going to write some examples, Mr. Dueck. That's what you're going to do. I go like this, I think. Click. Pen. Some examples. Anybody, what are some metals that you've heard of? Bronze is a mixture. It's actually not an element, it's a compound. But yeah, the fact that we discovered it and learned how to use it was one of the first industrial revolutions. Yeah. Lead. You got your pink periodic table? Look at your pink periodic table. Do you see there's kind of a thick black staircase line towards the right-hand side? Can you see it? Everything on the left is a metal. So, can you tell me some other metals? Boron.
Carbon.
Actually, boron is a metalloid. I lied to you a little bit. Certainly aluminum is. Everything to the far left. Oxygen is to the right of that staircase, is it not? So oxygen is not a metal. Nickel. Now, first thing, before I take more, as far as I'm concerned, because hopefully you've started to clue in that I'm fond of abbreviations, you can write them out, but I'm going to start to use the symbols because it's far less writing. Some of them make sense, some of them not so much. Where's my pen? Let's go black. The symbol for gold is AU. Can you find silver? What's the symbol for silver? AG. What's the symbol for lead? PB. Those ones don't make sense. The symbol for aluminum makes sense. The symbol for aluminum is AL. The symbol for nickel makes sense. The symbol for nickel is Ni. So those are some examples of metals. Basically to the left of the staircase, except not right touching the staircase, except sometimes touching the staircase. There's some gray areas with those metalloids, but certainly copper, cobalt, nickel, beryllium, anything to the left of the staircase. Non-metals. Those are the ones to the right of the staircase. And there's only a few of them. They are usually either at room temperature gases or brittle solids, except for bromine. Bromine is the only one that's a liquid at room temperature. And you know how you remember what non-metals are? They're everything that metals are not. So they are not shiny. They are not malleable. They are not ductile. They don't conduct electricity. So looking at your pink periodic table, on the right-hand side of that staircase, can you tell me some non-metals? And you'll notice I'm now using the symbols. Do you have to memorize the symbols? Nope, you have them on that pink periodic table. You'll memorize the most common ones because they're great shortcuts. In fact, probably you've seen the symbol for water. What's the chemical formula for water?
H2O.
Hydrogen, 2 hydrogens, 1 oxygen. That's a compound though, so we're not going to talk about that yet. Metalloids. These are the ones that have some properties of metals and some of non-metals. And I'm going to show you where they are as a picture. If you look at that staircase, you guys see that staircase on your periodic table, that big thick black line? The metalloids are, look up, those ones. Silicon is the really important one. The reason that our computer chips are made out of silicon, the reason semiconductors are made out of silicon is because we can make silicon conduct like a metal sometimes, and we can make it not conduct like a non-metal sometimes. And we can control that, which allows us to make computers at the microscopic level that are essentially on-off switches. That's what a semiconductor is. Someone had a hand up here and I ignored it for a second. Okay? Doing good? So, I fibbed a little bit with my metalloids. You can see there are a couple of rows of two. You know what? I'm probably not going to be doing much of a song and dance about the metalloids this year. I'm more telling you about them, Riley, because I'm a nerd. Now, tricky part. On your periodic table, what's the very, very first element? Hydrogen. How many times does hydrogen appear on your table? Twice. Why? Because hydrogen sometimes behaves like a metal and sometimes behaves like a non-metal. Hydrogen is a non-metal, except when you get to chemistry 11 and 12, you're going to see that there are certain situations where hydrogen can behave like a metal, which is why this periodic table puts it on both. Don't count it twice, though. Don't count it twice. It appears once, and I usually think of hydrogen as appearing over here, although it's also kind of nice to have element number 1 at the very, very beginning, which is why it's sometimes put there. But you can see on my color coding scheme here, hydrogen is classed as a non-metal. The metals are on the left, non-metals on the right, metalloids right along that staircase. Okay? I think turn the page. Turn the page. Elements that are close to each other generally have similar properties. They'll often bond with certain chemicals similarly. They'll often be solid or liquid at roughly the same temperatures, or gaseous at roughly the same temperatures. Those that are further away from each other generally have very different properties. So let's talk about the names and the symbols. First of all, look at your periodic table. Can you find element number 11, please? Sodium. Can you tell me its symbol? Nah. Can you tell me its symbol? Nah. Okay, there's your first nerd chemistry joke. Tell me a joke about sodium. Nah. That's the sodium joke, okay? They only get worse. They only get worse, but there's your first chemistry joke. Notice that sodium is on the far left. What's right above it? Immediately above it. Lithium. What's immediately below it?
Sodium.
No, what's immediately below sodium? Potassium. Okay. What you'll find is lithium and sodium and potassium will combine with the same types of chemicals, and they'll also behave in the same way when you drop them in water. They'll explode, which you don't know yet, but we'll learn that. Can you find titanium, please?
TI.
What element number?
22.
Okay. What's right below it?
Zirconium.
You'll find that titanium and zirconium will combine with the same other elements. So stuff that's in the same vertical row, those have very, very similar properties. Also, stuff that's right next to another element often has very, very similar properties. There's a whole bunch of information in this periodic table, not just the symbols, but how it's laid out was thought about very, very, very deliberately. Where do the names come from? Some are from Greek and Latin. You can fill that in. So who remembers, what did we say the symbol for lead was? That's not, sadly. This is one that comes from Latin. Can you find lead? PB? By the way, from what you know of lead, is it really heavy or really light?
Really, really heavy.
From what, find helium. From what you know of helium, is it really heavy or really light?
Really, really light.
Can you find gold? From what you know of gold, is it really heavy or really light?
Really, really heavy.
Based on that, what do you think as you move further down the table, are you getting heavier or are you getting lighter?
Well,
Okay? Further you go down, the heavier the elements are. We'll talk about why that is, but there's also, Nicole, a pattern in this table. What's the lightest element in the universe?
oxygen,
Hydrogen. How can you figure that out from the periodic table? It's the first element. Okay? What's the second lightest element in the universe? Helium. What's the third lightest element in the universe? Lithium. Okay, figure it out. Pardon me?
Where's oxygen?
Find it. It's on there. It's element
I
number.
know, but like I thought it was like the latest.
Nope. Oxygen, surprisingly heavy. Okay? So, back to our notes. Some are from Greek and Latin. Some of the more recent ones are named after famous scientists. So, Einsteinium is named after Albert Einstein. Rutherfordium is named after a scientist whose last name was Rutherford. Where do the symbols come from? Sometimes the Latin name for something, even though we use a non-Latin word as a name. For example, comes from the Latin word plum, from which, I kid you not, we get the word plumber. Now, why would lead be named after plumbers? Turns out when the Romans built their pipes, you know what they made them out of? Lead. Turns out when you make pipes out of lead, the lead leaches into the water and makes you sick and loopy. It gives you brain damage, which is why Romans were a little strange. We know better now. But only recently. Your grandparents, me as a kid, we grew up with leaded gasoline. So in the 1950s and the 1960s and the 1970s, lead was added to all gasoline because it made engines run smoother. But that lead didn't get burned up. It came out the tailpipe and it got deposited into the environment. And in the late 1970s, and it took a lot of doing because there was big companies, the oil companies, that had money invested in lead, they got lead gasoline banned permanently. Since then, we've done studies. The average IQ point of kids has gone up in the past 30 years because it was, I kid you not, damaging our brains in the 1960s and the 1970s. So we're not all that much smarter than the Romans. It says, see page 44 for a list and then complete the worksheet. We're going to come back to that. Well, you know what? Let's open our textbooks to page 44, please. If you don't have your textbook here, don't worry, I've got a copy right here. So here's page 44, and the chart we're looking at is this one right here. It has 35 common elements. As part of the homework, what the homework is going to ask you is to talk about where some of the names came from. So page 44. Well, helium is named after Helios, which is the word for sun. Anybody want to guess what the sun contains a lot of? Helium. Okay? Oxygen came from the word for oxys genus, which means acid forming. Really? Oxygen forms acid? It does in the right conditions, yeah. It's called oxidization. Sodium, symbol Na, comes from the word natrium, which is Latin for sodium. Iron, Fe, comes from the word ferrum, which is Latin for iron. So some make sense, some don't. Okay? Back to our notes. Mercury. Mercury's pretty cool. Mercury is the only metal that is liquid at room temperature. It's a very, 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 very thick liquid. You can write this down where it says mercury, liquid metal. Mercury is the only metal that is liquid at room temperature. It's so thick that if you put a drop of mercury on a surface, it almost balls up into a complete ball. It's got such strong surface tension. It's very toxic. We did not know that. So if you talk to Mr. Perugia, who taught chemistry for a long time, he'll tell you when they were in university, they literally used to play with mercury. You would pour some of it in your hand, it would ball up and you would pass it from hand to hand. But what you didn't realize was parts of it were turning into gas, you were inhaling it, and it bonds with the neurons in your brain and gives you brain damage. Okay? So we have since learned that. We're much more careful with mercury. Liquid elemental mercury is not that toxic, but the gas it gives off is. You'd have big problems if you ate it or breathed it. You may have heard the expression, mad as a hatter. The reason that expression came to be is 200 years ago, felt hats were preserved with mercury. And so it's thought that if you were someone who made hats, you were breathing mercury very, very often, and eventually you went insane. That's where the expression, mad as a hatter, comes from. Yeah, kid you not. This is a problem for your generation, unfortunately. Courtesy of my generation. You're welcome. We have dumped mercury into the oceans. We didn't know better. You know what? For a while we did know better and did it anyways because we're still doing it. Long-term environmental exposure to mercury is more problematic. It can lead to problems with your central word to fill in the blank is nervous system. It can affect coordination. It can lead to developmental problems in fetuses and small and young children. It can lead to birth defects, and this is non-reversible. We have no way, if you get mercury poisoning, we have no way of curing it right now. It's beyond our technology. Most of the mercury that we put into the environment eventually makes its way to the ocean. The mercury content of fish has gone dramatically up in the past 50 years. I'm reaching the point now where I'm becoming leery about eating seafood. I'm probably being a little overly paranoid, but once again, Rihanna, you're welcome. Here's an environmental problem. Your generation gets to clean up my mess. And I apologize on behalf of all the other adults that were stupid. It's very dense. So this is a picture here of a guy sitting on liquid mercury. He's floating. You can see he barely sinks into it. It's that viscous. It's that thick. Now that picture was taken about 40 years ago before we knew how toxic the gas was. There's no way we would do that now without him wearing a gas mask. But he is floating on a liquid. Where do we use it? Believe it or not, mercury safely is used in dental fillings, but we bond it with something else so that it's non-reactive. It's used in sparkless switches. Because mercury is a liquid metal, I'll take your question in a second. Because mercury is a liquid metal but will conduct electricity, you can have a switch where if you tilt it this way, the liquid flows to the bottom and the switch is broken. But when you tilt it this way, the liquid flows to this side and now electricity flows through this side. You can make switches that don't have any sparks, but they still work as switches. Question?
Is mercury like jello? Like
No, liquid. Like liquid.
No, like when it hardens? Is it
You
like
have to cool it.
slimy?
Well, no, if you cool it down to its solidification temperature, it becomes a brick of metal like any other metal. But I don't know what its solidification temperature is. I think its solidification temperature is well below 0. I think. I have to go look it up. It's used in mining to purify gold. Unfortunately, back when mines did this frequently, they then just dumped the mercury into the environment. They didn't know better or they didn't care. It used to be used in thermometers. Not anymore. The other place that it's used, and you should be aware of this, it's used in the fluorescent lights all around you. And now I have to go serious for a second. If you are in a room and a fluorescent light breaks, you need to leave the room for about half an hour because there is a gaseous powder that's drifting around that contains mercury and you don't want to breathe it.
What happens if you drink it?
It bonds with the chemical receptors in your brain. A tiny amount won't do anything, but it's going to add up. It makes your brain neurons not work so well. Now, you've got trillions of brain neurons, and so if you lose 2 or 3, meh. But if you keep doing it, it's a bad habit. It's avoidable. And again, we have no technology to remove mercury poisoning. No, it's science. Sorry, it's science. We're trying, but mercury is a weird element that way. Put your pencils down, look up.
Do we see that?
Nope. We're back. Okay. Next one. More explosions. Hydrogen. Hydrogen is the lightest, most abundant element in the universe. Oh, yeah, turn the page, if you haven't already, a while ago. Hydrogen is the lightest, most abundant element in the universe. It's very reactive, which means it's very rarely found all by itself in its elemental form. It's usually found combined with other stuff. On our Earth, water. Water is 2 parts hydrogen, 1 part oxygen, and we know how to break water back up into hydrogen and oxygen. We're pretty good at it. Hydrogen gas is very, 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 very flammable. It's one of the fuels for the space shuttle main engine. It's used during liftoff, and I'll show you a video in a second. Because hydrogen is so light, it was once used for blimps to keep them afloat. What would the problem with using hydrogen to keep a blimp in the air be?
Do they catch on fire easily?
How many of you have heard of the Hindenburg?
No.
Okay, so the Hindenburg, and this is a terribly famous story, in 1930, it was a blimp. There was about, I think, 40 or 50 passengers on there. This was before airplanes had become a way of crossing the Atlantic. Blimps would cross the Atlantic with passengers in great luxury. It was actually kind of a neat way to travel, but it was filled with hydrogen. It was coming in for landing, I think, in Chicago, and there was some kind of a spark. And you can, I won't show you the YouTube video, but if you Google Hindenburg YouTube, you'll find it. It's terrible because people are dying. There's a reporter just screaming as he's watching it, and you'll see it blow up. So now what are blimps? filled with? What's the second lightest element on the periodic table? Helium. What are your party balloons filled with? Helium. Helium is non-reactive. It's much, much safer and much, much stabler. The only problem is it's much tougher to get. Hydrogen was easy to get. Said I was going to show you a video. Put your pencils down. So we're going to pause here. Oh, where it says on your notes, what would the problem with this be? You can, you know what? From current slide, click. What would the problem with this be? You can probably just write that and you'll figure out what the heck we meant. What's your homework? So I have 3 things. I have a sheet called the Survey of the Elements, a little sheet called Exploring the Periodic Table, and section 2.1. And I think you can probably get it, because I'm giving you 25 minutes, you'll probably get it all done in class. Let me walk you through what they are. Pause the video.